All right, everyone, we're going to get ready to get started here. I'm Bill Carpenter, the VPR HPC Systems Lead, and today it is an honor to introduce Jim Wilgenbusch, the Director of the Research Computing at the University of Minnesota, Twin Cities. Jim is responsible for the strategic direction and leadership of the four major computational research areas under the OVPR. This includes the Minnesota Supercomputing Institute, U-Spatial, the International Institute for Biosensing, the Data Science Initiative. In this role, Jim leads university-wide initiatives, partners with collegiate senior administrators, and works with faculty and admins to shape research computing at the University of Minnesota. Jim is also involved at a national level in the promotion and development of research cyber infrastructure. In addition to all of this, Jim maintains research activities in the study and implementation of models, methods, and software used in phylogenetic inference. So let's all give a warm CSU welcome to Jim Wilgenbusch.
Thank you, Bill. Can everyone hear me okay? I'm going to assume a yes on that. Great to be with you. I apologize for not being there in person. I sincerely wish that I could. However, as I'm sure everyone here can relate to, this is a busy time for all of the regular reasons and then some. And so I had a number of obligations today that unfortunately kept me from being there in person, but I sincerely would like to for this great event. And so thank you again for the invitation, especially Michael Kirby for the engagement in this effort. This is a fun time in terms of this area of research, and I wanted to give this some context in terms of the three areas that are actually a significant part of this effort, and also a huge part of what we've seen, generally speaking, around data science, AI, and computation. And so I looked, so what does one do to provide that context? And what I did was essentially go to Google Trends to see how these keywords, computing, data science, and artificial intelligence, are faring in terms of those, the Google metric that they use for trends. And what I found was actually surprising, the degree of convergence in these three fundamentally important areas. As you can see, computing as a search term has diminished relative to these other areas, while things like data science and artificial intelligence, not surprisingly, in certainly the last 10 years, have increased to comparable levels. And that convergence to where we are right now, I think, really speaks to the importance of what is happening at CSU as well as universities throughout the US. And so it's with that sort of notion that I'll give a little bit of background in terms of what I do, and then hopefully end with some insights around what has helped, I think, in my personal efforts to advance research computing at universities that I've been a part of. I was not sure if there would be an opportunity for more discussion or questions, but I am certainly happy to field any questions and would embrace the opportunity to hear from people who are in attendance if there are ideas about anything that I present today. And so if there is an opportunity for that, again, I welcome it at any point that is appropriate given the forum. All right. I have also made this presentation available, and so I wanted to just list these here to say that I'm drawing heavily on things that have been published in the past. And so if you wanted to sort of dive in more detail to anything that I'm covering, these particular papers, which were largely published in the PERC ACM journal, would make that information available. And so hopefully you'll have this slide deck and you can get into these specific citations. Otherwise, reach out and I'm happy to provide more information. The other thing that I lean heavily into when I think about campus research computing in general is the notion that the National Science Foundation, I think, has done a very good job at projecting, and that is that we're really attempting to develop a cyber infrastructure ecosystem in general. And that ecosystem includes especially data-driven science and research in general, and that the opportunities for doing that effectively are huge, but there are also very, very realistic challenges associated with developing out this missing middle. And again, my focus will be on how I very specifically have attempted to target issues pertaining to challenges related to data, not ignoring the fact that the computing side of things is also critical, but again, just placing that emphasis on challenges related to data access, data discovery, and what they're calling data fusion, or making data more interoperable and integrating those data at scale. All right, why does it matter? This is critical to me. I don't like talking about research computing and data in the absence of the applications that are supporting that need these resources. And so it matters essentially because there are incredibly important questions that depend on resources. I love working at the University of Minnesota because these are the real examples that I deal with on a daily basis. We have a very, as does CSU, I know, because we partner with them in the AI Climate Institute, how to feed a growing population that's threatened by global climate change. How do we develop new materials needed to transform energy and transportation systems is something that the systems we work on are critical. And we have a hospital system here that we're now directly engaged with, given a new system that we put into production for PHI. How do we effectively diagnose and treat various forms of cancer? And then I'll talk a little bit about the collaboration that we have with the Masonic Institute for the Developing Brain. But how do we address the growing epidemic of drug addiction and other mental health issues? These are things that, again, keep our staff and keep me focused, and also really every day enjoying the work that we're engaged in. And so I'm sure you have numerous examples as well that you could lean on and that were discussed today. A little bit of context in terms of what I oversee. As Bill mentioned, I oversee a number of different institutes or organizations under research computing. Bill mentioned 4. A 5th was very recently added, and that was Sustainable Geocommunities. That's a brand new organization that now fits under my portfolio and is responsible for developing solutions and is receiving, we've just seeded 5 different grants or different programs under that umbrella that are active right now. And so we have the something that we call USpatial. It's on the Twin Cities campus, and we also have staff on the Duluth campus. We have now the International Institute for Biosensing, which is about 2.5 years old and maturing in very exciting ways, developing partnerships that extend throughout the globe. We have the Data Science Initiative, which I'm happy to report actually is undergoing an evolution, and that evolution now will be seen in the form of a new name called the Data Science and AI Hub. Something that I unfortunately don't have time to talk about, but would love to answer any questions that folks may have about how we evolved the Data Science Initiative into the Data Science and AI Hub. And the Minnesota Supercomputing Institute, which has been around now for almost 45 years. And as I mentioned, our newest member of the research computing family, Sustainable Geocommunities. In general, what all of these institutions do is that they engage and collaborate. They specifically work on ways to do that. We also, in terms of sort of our actual hardware or physical infrastructure, we enable and accelerate. We do a tremendous amount of training and engagement with communities both on and off campus. And then we provide funding to innovate and also to help seed various programs that might need additional support. And so the breadth of things that we cover under research computing is fairly large. We do that with a little over 100 staff who are engaged in these various programs, and in many cases are specifically funded by sponsored research projects. I mentioned earlier some highlights. One that I want to call attention to again is the Masonic Institute for the Developing Brain. We've been partnering with this organization now for about 3.5 years, and it's yielded significant impacts to people who are being treated under the Masonic Institute for Developing Brain. But also we've been able to secure funding that has helped us to sustain those efforts. I also mentioned that we are a key collaborator for one of the national AI institutes. That actually will bring me to your campus in a few weeks for our second annual all staff, all hands meeting. And so I'll be at CSU in a few weeks. And then there are a number of other departments, actually, nearly every department on our campus that is engaged in some way with the entities under research computing. And I also mentioned the broad way in which we're actively training and supporting various broad engagement efforts with our community. All right, so just again, because this is about sort of research computing infrastructure, I wanted to give you some context in terms of how we operate. And so research computing contains the various organizations that I've mentioned as a cohesive group. And so my staff sit together in 2 buildings, and we frequently meet with one another in person, over Zoom, and so forth. But the idea is that there are opportunities for synergies among these various groups, and that's why they are together under research computing. The Minnesota Supercomputing Institute has been around the longest, but these other organizations now have a history that spans from 10 to most recently 1 month in age. These groups also engage with other communities on campus, and so we have direct engagements with the Masonic Institute for the Developing Brain, Lab Medicine Pathology, the GEMS Project, the Institute for Translational Neuroscience, and so forth. And so those relationships involve actually directly staffing areas of support that are aligned with those unit's interest. And so in the case, for example, of the Masonic Institute for the Developing Brain, we actually have 15 staff who are directly engaged in that effort. With lab medicine and pathology, we have 6 staff who are fully paid for by lab medicine and pathology, but we actually hire them, we supervise them, we house them, and we help nurture them as staff persons. And so this has been a very healthy relationship that has allowed our staff to have groups of people who are like-minded and share common interests. We have a history at the University of Minnesota being involved in supercomputing. This history actually dates back formally to 1981, when the Minnesota Supercomputing Center was first developed and housed the first university-owned supercomputer. Seymour Cray was an undergraduate here at the university, or was a graduate student, I'm sorry, at the University of Minnesota. We've also been home to the Army HPC Research Center, and we've had top 500 systems on the top 500 list since the top 500 was created. And so that history has really helped in many ways support our research enterprise by providing, again, a very consistent level of access to compute resources to support engagements with external industry, as well as students' theses and faculty research. The engagement is broad, and this has grown to be the case probably more so in the last 10 years than ever before. But as I mentioned a little bit earlier, we engage with 116 different departments across the University of Minnesota system. We have over 1,000 PI groups. We're organized principally around faculty-led groups. We have actively utilizing the system at any given point up to 5,819 users. And these users are actively renewing. So these are not legacy accounts. These accounts they're required to go through an attestation process once annually, at least. And so these are users who are actively engaged with our systems. I wanted to take a step back just a second to say, I also directed a smaller operation at the University of Florida called Research Computing, and there we also developed or deployed a number of resources. Our purview was much, much smaller. It didn't include the other institutes, but it did include a fairly decently sized menu of research computing assets, from high performance computing to various forms of data storage and consulting and planning services. FSU, interestingly, also had a fairly significant and long history in computing. And so I was really happy to be able to work to evolve that history into what is now known as the Research Computing Center there at FSU. All right, so what does this mean in terms of requirements? And I wanted to take some time just to sort of, again, give my 2 cents as to what is required to successfully launch research computing on campus, and to address some of the things. This is where I was hopeful that there might be an opportunity for questions, engagement, maybe differences in opinion. But if there isn't a means to do that, at least you'll have sort of this insight to look to. The first, I think it's imperative to define a value proposition. What are you specifically attempting to do with any sort of campus-based research computing infrastructure? And that process of defining that is one that by itself is a fairly significant activity. And I know, having engaged with Michael in the early stages of the proposal development, that this was a big concern of his, and is something that is happening at CSU. But this is an important sort of first step, is really defining that value proposition. Also, then building this solid operational plan. What specifically are you going to do to advance that value proposition? Part of that operational plan should certainly include how one goes about developing a robust infrastructure, while also accommodating room to experiment. And so, I think it's important to be explicit about accommodating both of those things and distinguishing them very clearly. So again, expectations are appropriately set. Likewise, what in that infrastructure, what plans are built around accommodating software and other tools that will be essential for the relevance of that infrastructure? And what sort of user support and training will the institute or center be a part of deploying, and being explicit about that? The second sort of baseline requirement, one that I'm going to dive a little bit deeper into the importance of spending time considering, is the staffing element. The people are, in my experience, the most critical element of your cyber infrastructure, and really understanding specifically what incentive structures are needed to attract and retain good people is something that is frequently overlooked, or in some cases confounded with other incentive structures at academic institutions. Very often, your staff do not have the same incentives as graduate students or faculty. And so being explicit about what incentive and structures are important to deploy, I think, is a critical requirement for a successful campus-based research computing facility. What I wanted to do is just spend a little bit of time in terms of sort of how explicitly I've worked to understand this space. And so on the people side, very often the issue is, how do we scale our staffing? Because they're a limited resource, and they're constantly in demand for a variety of different things. And so in two dimensions, you can imagine a case where maybe what your leadership wants is full cost recovery, right? I would love to see all of the staff paid for by various grants and contracts, right? And that probably isn't realistic in all cases that we experience at an academic institution. Likewise, I think maybe what some of our faculty would want is that it's fully subsidized in terms of the staff that we have. And so that continuum is something that we should consider, that continuum potentially of desires. Likewise, from the standpoint of solutions, we can imagine that we get economies of scale when we when our staff provide broad solutions, right? Maybe that is in the form of a simple help desk. And when people have questions, they can send us those questions and we can kick out answers, fairly easily, or we can create documentation that gives people, in general, a way to effectively access and utilize the systems. But it ignores the fact that there are often cases where our staff might be needed to develop custom solutions for very interesting use cases that maybe don't fall in the case of those broad solutions. And so how do we deal with the potential pull that our staff might feel in this sort of space of these conflicting interests. And so the way that we've addressed them is actually by coming up firmly with concepts about what we do and how we staff in these potential areas of this space. And so we have this concept of consultations, and we're explicit about it from the standpoint of we need to have this and we need to staff appropriately for it. And what it means for us is that these are typically shorter term engagements where someone either by email, Zoom, or in-person contact is working with a staff, student, or faculty member, generally speaking, less than an hour. And there are no direct costs associated with this for the entity. That's something that we're committed to providing, and we can do generally in a sustainable manner with our existing staff level. We've defined this other area that falls a little bit to the left and the lower left quadrant, and we call these collaborations. We define these as dedicated research involvement, probably involving in some cases weeks to months of commitment per project. And we see and define these specifically as a win-win for both the group that is involved in this project that is outside, let's say, of our staffing infrastructure, as well as for our staffing infrastructure in general. So for example, maybe the collaboration is a tool that can then be more broadly utilized by the university research community, but perhaps has that engagement level outside of research computing that is needed to effectively advance the goals of this. And so the win-win involves sort of that in-kind contribution to the success of the project, but there's typically, again, no money exchanged, just a sharing, if you will, of effort. And then the third area that we view as being critically important for our success is to have a way to engage in what we call partnerships. And these partnerships are distinguished from collaborations in the sense that these efforts are typically taking us away from perhaps a common goal and focusing on a specific dedicated effort. We define these partnerships typically around a memorandum of understanding with clear expectations around funding and what our commitment is to that particular project. And we're involved heavily in a number of these partnership projects to the tune of about 25 FTEs are directly engaged in these partnership opportunities where they are essential for the success of various well-defined projects. All right, so that I just wanted to dive into some of these specific components to a successful HPC to give a little bit of depth and color to what I mean by some of these things. Each of these things that I'm pointing out has a similar sort of set of principles underlying them, but I obviously don't have time to go into all of them. As part B, develop governance is critical. Make sure that it's right-sized, right? So the governance here at the University of Minnesota with our larger purview under research computing may not be appropriate for other instances of research computing. Think about your stakeholders. Obviously, the stakeholders involve many of the different disciplines on campus, but also include other campus technology research providers, and ways to engage with them are things that I would love to be able to have more time to talk about. And communicate. All of this needs to be communicated in a way that that constituents feel as though they understand what's happening at the research computing center. This gives us an opportunity to set expectations. I've just repeated that twice intentionally because it can't be done once, and with the expectation that everybody understands exactly where you're headed. This needs to be done constantly. And so through communication channels, there needs to be some means by which you're constantly setting expectations and hopefully also developing a way to project your value proposition specifically. Define your approach, and here's specifically what I mean by that. There are, in general, two ways that I have seen centers go about this. I'll describe one as quick wins, or the other one could be robust infrastructure, right? And so you have to consider that based on what specifically you're doing. And this applies not only to the Institute as a whole, but I think as you actually decide to roll out projects, do you want to demonstrate a quick win and then go back to try to shear up the infrastructural components? Or do you have perhaps the latitude, the time to develop the infrastructure first and then roll out perhaps examples or wins on top of that infrastructure? And having a clear view of your approach concerning whether you want to do quick wins or spend the time developing upfront that robust infrastructure, I think is an important determinant of success. All right. So this is bringing me up to the end, and I'm sorry, I know we are right up to the last of my time, but these are just a few things to, I think, answer that question since I posed it by the title. What is the role of campus-based research computing? These are essentially what I would consider to be elements of the value proposition or potential return on investments that you might be able to use to measure impact and things that are important to consider in terms of rolling out effective research computing that is campus-based. And so that is my last slide. Again, I'm sorry I can't be there in person, but I'd be happy to entertain any questions that folks may have.
Thank you, Jim. I'm going to kick off the questions here. Could you speak a little bit about the evolution of the data science AI hub that you'd mentioned earlier?
Yeah, thanks for that question. So 2 years ago, we were after a faculty-led effort to develop a data science initiative on campus. We were charged by our provost to develop a system-wide report on what the university could gain by having a data science initiative. And that report then led to some funding that came from our College of Medicine, the provost, our OVPR, or our vice president for research, and our dean of the College of Science and Engineering to move forward on elements of our report. And so that funding was enough to get started a variety of efforts that attempted to elevate the various independent data science activities on campus. Well, in the intervening years, AI became an obvious and almost an obvious and completely associated component of the data science initiative. And so that's when we pivoted to suggest that we needed to evolve the data science initiative to explicitly include AI. And and our proposal was to focus on the creation of a hub that would have as its initial thrust a strong facing industry component that would engage with our area industry. We have a number of Fortune 500 companies in the Twin Cities that we engage with regularly. And secondly, it would specifically serve to help projects that were in need of team science activities related to data science and AI. And so we have recently been given that new mandate under the Data Science and AI Hub. And we're now in the process of securing resources, both internally and externally, to advance that no longer initiative, but actually hub.
That's great. Thank you.
Yep.
Who else has questions?
Hi, Jim. Michael Kirby here. Thanks very much for a great talk and really a roadmap on how to establish a computing facility.
Hey, Mike.
I hope to meet with you when you come to CSU in a couple of weeks. That'll be great. But I'll just pose one quick question now. In terms of how do users interact, it looks like you've been at this for a long time, and you're probably well past anything like a condo model where people are adding to your system. How do faculty, let's say, how does a chargeback? Is there a chargeback system? Is there the cost
Michael,
recovery? Yeah, go ahead.
A fantastic question, and I appreciate it. We had a system when I arrived here 11 years ago where there was actually no mechanism to do that. The University of Minnesota had a long tradition of buying assets that were centrally funded. That was nice on a number of levels, but it also precluded people from easily getting dedicated resources. And so 7 years ago, I worked with our sponsored research organization and our audit component of the university to accommodate what we now call dedicated computing. And so the way that we actually do that is because we have recurring funds that we escrow for upgrades to our system, we generally buy larger than what we might be able to budget for, with the idea that over the life of that system, let's say in our case, we depreciate our systems over 5 years, and that's probably pretty standard. That's actually the way that it worked at FSU as well. So over that depreciation period, our expectation is that we capture through dedicated computing some amount of cost associated with those systems. And so what that means is that we do actually sell components of our large scale systems. Those are for sale, either at a 1-year term, or they could be as large as for 5 years. And we also have secured a commitment that those resources, even though they are technically services, are not subjected to our F&A rates. And so there's one price for our dedicated compute nodes, whether you're coming to me with, let's say, startup funds from a department or federal grant funding. And so we have a waiver for assets that are part of our system. And so we actually have numerous users now that have bought into the system. Our committee, we have an advisory committee specifically on utilization of the system, is responsible for setting a percentage of the system that can be sold, so to speak. And so we have that committee sort of controls the knob, if you will, for how much we can cut in to our general access systems, which are available on a first come, first served basis or a fair share model. And so that's a great question. I think it's very important to address. Ours is somewhat of a condo model in the sense that we do have owners specifically of dedicated access to our system.
Great. What fraction of your system is owned under that model?
Right now it's 40%, and we're actually going because like many of our institutions today, we're experiencing some fairly significant budget cuts. We're actually going to that committee to see if we can accommodate a greater percentage through dedicated computing to increase that percentage. There is the demand for that on campus, but we have done a lot to try to reserve a fairly large portion of our systems for the fair share.
And
But it's hard for us to sustain that.
would these be generally faculty who are buying into the system, or do you also get departments and or colleges buying into the system?
Yeah, that's a really good question too. Generally speaking, it is faculty, but we absolutely do get departments also buying in. I'll add to that, not only departments, but some of our institutes on campus have, over the term of time that we've made this accessible, they've completely gone away from developing their own HPC infrastructure to utilizing ours under this framework. And so they buy in typically 5 years and just let MSI support their HPC and data storage needs. I'll add one more to that. We do actually have what we call an ESO here, an external sales organization, and we have some small number of contracts with external organizations, industries that use our systems by buying access. But I emphasize small. We're not geared to sell to external organizations, in part because we're a state organization and we're not trying to compete with other providers. We only do that in cases where we can demonstrate that there's other collaborations associated with the University of Minnesota that would necessitate such a buy.
Great, thanks. Yeah, I think we have the same restrictions in the state of Colorado.
Yeah. So we upcharge those to what other service providers would charge, and so we actually get a profit from that, and I report that profit and pay a tax on it.
Any other questions from the audience? All right, let's get another warm round of applause for Jim. Thanks so much for doing this.
Yeah, thank you. And again, sorry that I can't be there. And Michael, when I come in a couple of weeks, I'll be sure to look you up.
Great, thank you. Thanks everyone for coming. Thanks, Jim. Thanks to all the speakers. Anyway, thanks. At the end of the day, thanks is due to all the speakers that came from long distances in some cases. I know Penny had to leave early and she got stuck and the airport was closed yesterday. So I want to thank everybody, give them a round of applause. I'd like to thank the session chairs who did a nice job of introducing all of the speakers. And lastly, but not least, I'd like to thank Brandon, who organized this whole event and did a great job. All right, thank you very much.